Hello, good morning, LinkedIn. I've tested, installed, and commissioned millions of batteries at over 650 data centers around the world. And I wanted to share some of my expertise, knowledge, and experience with you guys this morning on the evolution of this industry. We have data center construction projects going on all around the world. There's billions and billions and billions of dollars. You looked at last quarter, Microsoft posted a $23 billion profit in their cloud computing margin. This all comes from data center or edge facilities. But without the battery, none of this is possible. Most of you don't realize every time you connect to the internet, on Amazon, on Google, on Facebook, on LinkedIn, every one of these businesses have, significant critical infrastructure, buildings that are millions of square feet, that stretch acres and acres and acres, especially out here in Eastern Washington and down in Oregon with Facebook and Prineville. They're very critical, but without the battery, none of that is possible. And a lot of these different organizations also add in flywheel systems, like the old Pentadyne flywheel system. But those only offer 10 or 11 seconds. You have to install several of them in parallel to get up to 45 seconds or a minute. And then they usually install some kind of a hybrid battery system to get them up to 5 minutes. Because mainly what these battery backup systems are doing is maintaining the critical load during an outage or a weather event or some kind of an emergency until the diesel generator can spin up. That's it. That's the major focus for that. For you as a consumer, batteries are every day in your life. Take the battery out of your phone and take the battery out of your car. Now drive to the store, call your mom, and send an email and tweet. You can't do any of it without the battery. It's very important. But in the data center industry itself, we need to focus on the key metrics for this. And I think one of the more important aspects of these new features is something called a reconditioning feature. There's companies called BACS, B-A-C-S, and EMSIS, which are using voltage dividers in the LEDs to increase luminosity or decrease the brightness to inherently control the state of charge on the battery system individually, the state of charge. So 1.75 volts per cell times 6 individual cells for a 12-volt monoblock, you should maintain it around 13.5 volts. Now, why is this so important? Because mostly in VRLA batteries, valve-regulated lead-acid batteries, or VLA batteries, more specifically on VRLA batteries, you can't add any more water to them. So if they're not controlled, if they're overcycled or overcharged from the UPS, they can vent hydrogen. So they lose water, they dry out, the internal resistance goes up, and thermal runaway can occur. International Fire Code 608.3 mandates that you should have some kind of a tripping mechanism on the breaker if it measures over 1 amp or 1.2 amps or whatever the pre-programmed threshold you have set in place. It'll trip that breaker, or it'll notify you right away that there's some kind of a system in place. Obviously they couple that with temperature monitors itself, 3-wire thermistors or whatever. They're going to have them both together, say, okay, we have 95 degrees, the charger's not temperature compensated, or it is, now we're going to trip it at the breaker. You have to have these mechanisms in place. But the reconditioning feature of this, to me, is the most advanced as compared to the conversations we've had for 12 years. Is conductance better than impedance? DC resistance is the best. They use it at all the nuclear facilities, right? We look at the tail of the whip, the coup de foie. We want to measure the voltage characteristics here, the voltage characteristics here. We take that delta V, we put it over the induced current, and we get RINT. That's the indicative of the true capacity of the battery. That's not true. The only way you're going to get capacity of the battery is by running a load test at 100% or 80% of your stated capacity. You have to run the batteries down. You have to make them work. My analogy is, when I always talk to people, is if you look at someone, do you know how fast they run a mile? Right? By just looking at a battery system, if the voltage is okay, it's all right, it's no big deal. That's not true. You have to make it work. Just like you have to ask somebody, I want you to go run a mile, and I'm going to measure you every lap, up until you finish 1,600 meters. Now I know how fast you can run that mile, and if you do it 3 times, now I have a baseline, an averaging algorithm. That's important to understand what the baseline is for your battery system. I call it BSR, or battery string resistance, coupled with that capacity, is going to give you a true metric of the state of health of your battery system. Now, these battery systems are so important in the future. We have energy storage. We talked about this just a few days ago, that energy storage and energy density are key. Watt hours divided by kg or kilograms is going to give you that energy density metric calculation. There's your formula there. But the reason it's so important is because we're capturing energy all over the world, and in order for the United States to have enough energy captured just from photovoltaics, we'd have to have a solar farm the size of the state of California, just to be able to have enough space to capture that. That's just based on current efficiency metrics. Not even looking at some of the DARPA-funded projects or MIT as well, but just at the current efficiency, we need that size. But also, more importantly, we have to store it, because if you look at some of the solar farms down in California, they're actually producing more energy than they can store, and it's wasted energy. So it's very important to understand how much space we're going to need in energy storage, and batteries are very important metrics of that. And data centers itself, I think, are going to be, in the future, here's my opinion, that data centers will be a producer of energy. Not just a net zero, this isn't a zero-sum game here, but they will be a producer of energy. You see, if Apple has made these game plans for them along the way to be 100% on renewable. Google's done the same thing. Microsoft's right along with them as well. Facebook's not too far behind, but they're going to shift gears where they're going to have a revenue generating portion of their business that is now just, going out and capturing energy and storing it and selling it to either local communities or other data centers or etc. But let's come back to the battery system itself. So the major focuses for the battery monitoring system, you should have a reconditioning aspect there. It's 2019, guys. It isn't 2001. Okay, so you should have a reconditioning function there. MSIS and BACS are my two recommendations for that on the system. But you need to monitor individual cell voltage. Almost every single monitoring system does that. It should have a voltage divider circuit. Ask what the analog to digital converter spec is. If it's only 4,096 count, that's representative of voltage, 4.096. That's how many counts there is on the. You want to have that, instead of a 12-bit ADD, you want 16-bit ADD, so you have more space. That means you don't have to scale things down. So if you have a 540 volt DC input, you don't have to scale it all the way down to 2 volts. That messes with efficiency, but also resolution per calibration on your calibration constant. But as you look at the overall voltage as well, you want to measure that metric. That's going to give you the UPS efficiency, whether or not you have any kind of imbalances there. It's not going to tell you if you have any AC harmonics on your DC bus. This is often skimmed over, especially in older UPS systems that are running on 6 pulse SCR technology versus instant gate bipolar transistor, IGBTs. Now the new Toshibas and Mitsubishis, they're running at 60 kHz for these 6th or 7th generation IGBTs. They literally have zero noise on the DC bus. But if you compare this to older UPSs in the 1990s, early 2000s, many of them are putting 5, 6, 7, 10, 15 amps of current, AC current, back onto the bus. I mean, there's also a voltage that's represented there as well. But that cycling of the current there, what does that do? It heats up the battery. That's not good. Any kind of external heat near a battery is not optimal. We want to keep them near 77 degrees unless you have, one of the Enersys thin plate pure lead batteries that are designed to operate at 95 degrees, so you can increase the temperature, operating temperature in your data center, thus saving some cooling. Cooling money, then okay that you're having it. But those batteries are 2 to 3 times the cost of other types of battery systems. So most people have to operate the data center around 77 degrees F or 25 degrees C. But also in the battery system, you need to measure ambient temperature inside the cabinet and temperatures at the battery terminals, either positive or negative. If you can measure it on the negative, that's better in a VRLA system. That's where everything recombines. Okay, that's where it's going to be the hottest. So you want to have all those metrics there, but you also want to measure internal resistance. So internal resistance can be DC resistance. You have a load bank, an actual physical load bank with, at 54 volt load steps, which is inducing at 1.6 amps in parallel there, 32 amps across that load bank. You have 10 load steps in a 540 volt DC bus system, and then it's going to give you an internal resistance baseline for all those batteries. You want to do that initially when you install and commission them, and then trend them up through the life of the battery. Most warranties are around 3 years. You're going to fight your battery manufacturers for warranty. And trust me, if you don't keep all your documentation, it's very important. So weekly, monthly, quarterly, semi-annual, and annual inspections, you need to keep every one of those documents, and having a permanently installed monitoring systems help you do that. It'll help you recoup some of those costs because batteries do fail. I mean, they're not they're not infallible. They have a finite lifespan, and ambient temperatures vastly impact or negatively degrade those battery systems. So you need to have that. But understanding the differences between DC resistance, AC conductance, and impedance is very important. And mainly what it is this. I'm going to put it out there for you guys, okay? The bigger the battery system, the bigger the amp hour of the battery, the lower the resolution that impedance and conductance based monitors will have. That doesn't mean they're not going to find a bad battery. That doesn't mean that. It just means that it's going to take a little bit longer because there's a formula called 1/2 pi times F of C, and that formula is representative of the reactance of a battery. Now the 1/2 pi, the F is the frequency of the testing device, and C is the capacitance of the battery in amp hours. So it's a very easy formula. But generally, if it's permanently installed, you're going to have a baseline there anyway. But I just find that DC-based systems end up finding faulty or degraded batteries earlier. Those other ones still find them. That could be 3 or 4 months later. And why is that bad? Because an outage could occur by the time you end up finding batteries. But also, as we're discussing the resistance, functionalities here and these algorithms, you look at internal resistance, right, of just the battery, but also the intercell or intertier batteries. As you look inside a battery cabinet, there's generally 4 or 5 different trays. Each one of those trays may have 10 batteries in it, but there's a cable, a conductor that goes from the negative of the bottom tray to the positive of the next tray. You need to measure that resistance. You have to. It's very important, especially during battery maintenance. If somebody just came and installed a brand new battery system and they didn't measure all the internal resistances across the cables, and one of them is loose and under a discharge, you have 600 amps going through that cable at that terminal, what's going to happen? A fire. A fire is going to happen. So you have to measure that, but it's also important under discharge, because during discharge you have to add that voltage that's dropped across the cable, that'll be negative, back into the cell, because when you look at the cell voltage screen, the cells will be lower if you don't add those in. And you see those in monitoring systems that don't have intercell or intertier channels input to the analog to digital circuitry in the microprocessor. All of these things, they sound comprehensive, but it's mandatory things that you should have as features in your battery monitoring system. They're very expensive, and you should be asking these questions. What do they have? But also, very importantly, what is the service structure of your organization? Do you have 300 engineers around the country that can provide 24/7 support? Or did you move your manufacturing facility to Mexico and now your quality control has gone down the tubes and you're still selling all of your battery monitoring systems to these big data centers, but you don't have anybody to support them? That's a problem. So you need to ask these vendors, and there are a lot of them. There's quite a few out there. How do you support this product? Do you support remote support? Are you doing mixed reality? Third-person support with holograms? Are you integrating new, emerging technologies on top of your battery monitoring systems? Or is it just like 2002 where everything is hardwired in and nothing's wireless? The only wireless system that I know of, that's really efficient is one that I've been installing is MSys. The MSys system is fantastic. And that's another issue I have with all these modular-based systems on monitors is that if you're connecting them together on 40 batteries and they're all communicating via fiber optics, you need to ensure that it has a parallel path there, because if one of the modules fail, then that power supply shuts down. What does that mean? Fiber optics stops communicating not only to the next one, but the whole string. Fiber optics communicates from first to last, right? Receiver, transmitter, receiver, transmitter, receiver, transmitter. If that one dies, the whole system dies. So you need to ensure that the engineering team for that company or that manufacturer has implemented that, because we saw that with some of the Canera systems, where they would fail, one puck would fail, and the whole system would stop communicating. And the customer would call us and be like, well, there's no lights on. Well, we go in there and spend a half a day troubleshooting, and it's only one bad puck. So you need to make sure that some of the new systems do have that, but many of them do not, and they don't explicitly say that in any of their documentation, that this is a big point of failure. And also calibration and training. Is the manufacturer going to pass on skills and expertise and knowledge to you? That's something that I do for every one of my customers, is I train them as well or better than anybody else I could train. I give them every every piece of my knowledge. I'm not afraid of job security because I'm always building on my skill sets. So when I go to a site, I'll train them on the software, I'll train them on electrochemistry, I'll train them on harmonic analysis and the EPSs, switching processes, battery monitoring itself, the security and how to implement and run your weekly and monthly reports. You want to empower your customers. You don't want to take all that stuff away and hold it, right? Because eventually, in my opinion, what ends up happening is those customers leave, somebody else comes back in, and they replace the monitoring system. They don't feel important. You have to put your customers up on a pedestal and give them all the tools necessary to be successful, in this industry. Data centers are not going away, and in my opinion, they're going to continue to build many more data centers in the future. We're going to need them for the coming mixed reality and cloud computing paradigm. I mean, the spatial computing paradigm it's about to hit us here in 3 or 4 years. We are going to need edge data centers. We're going to need huge, infrastructures around the world that are all communicating, with some of these GPS down to 1 centimeter for resolution and accuracy for AR and MR shared experiences. All of that computational power has to go somewhere, and data centers are built to handle it. So we're going to need it. So understanding all these different aspects of batteries and battery monitors is really important. I mean, right now, without the battery system itself, we wouldn't have the internet. You wouldn't have cell phones. So those kinds of important aspects to this technology need to be taken in. And somebody who's interested in, how do you get into battery technologies? Do you go to school for this? Do you just join a company? Well, my recommendation is to join a company, some kind of a maintenance testing company, as an apprentice. You say, listen, I'm really excited. I'm very interested in this. I want to become an electrician first. Trade schools are amazing. I wholehearted recommend them to people, man. Especially up here in Seattle, as an electrician, you can make $50 to $80 an hour. That's unbelievable. As a journeyman and as a master or as a senior trainer, you can make even more than that in trade schools. But just because you're an electrician doesn't mean you're a battery expert as well. So you tend to have to focus on this, but you can also go to school. So you can go to school for material science, all the way up through a PhD where you would focus on this. There's national testing laboratories. Go to work for companies like Tesla. That is a major focus for them on the energy storage side. If you have any questions about this, I'm a resource for you, for everybody out there. Please feel free to contact me, reach out to me, let me know. I can put you in touch with people that are hiring. I just want to help you guys be successful and put you in a position for true happiness, really, because I love batteries. It's one of my, my greatest focuses in life. I was talking to a vice commander in the Air Force down in California the other day, and some of our, back and forth about that other post I have, and he said, clearly you love energy. Yes, I do. I absolutely do love it because it's the future of the human race. The study and advancement of this is definitely going to help us overcome many different aspects of, the degradation of poverty impacts on various parts of the world. If they had 100% renewable energy, which is based on that battery there, if they were able to have that in their village or their town, boy, it would give them just tons of strength and power to go out and find other opportunities. Again, guys, I want to thank you so much for always tuning into this channel. And if you have any questions or if you have interest in this, reach out to me, send me a straight DM, and I'll get back to you as soon as I can. Hope you enjoyed this message this morning, and I hope everybody has a wonderful weekend. And if you're in Seattle, get ready, because at 1 o'clock, we're going to get about 6 to 8 inches. All right, guys, have a great day.